Hey guys, been a long time since we made a video. Today we're going to do a video on permutations and combinations. Remember, a permutation is used to arrange objects when the order is important. Okay, so we talked about first place finishes, second place finishes, that kind of thing. Electing school officials, president, vice president, that kind of stuff. To calculate a permutation, it's pretty simple. So let's just take an example of a permutation of 5 things chosen 3 at a time. Okay. Well, this right here tells me how many slots I have available. If you think back to our teddy bear notes, I would have 3 spots on the shelves, and this number, the 5, represents how many bears we have to choose from. Okay, so I would have 5 different bears. So we start at the top with 5 times 4 times 3, and that's it, because we only have 3 spots available. So 5 times 4 is 20, and 20 times 3 is 60. So there are 60 possible ways to arrange 5 bears on a shelf that has room for 3 of them. For a combination, now this is something that we use when the order really isn't important. Okay, we used, as our example in class, we talked about a pizza. So it doesn't really matter what order you place the toppings on a pizza, it's still going to be the same pizza. So sausage pepperoni is the same as pepperoni sausage. To do a combination, let's say we've got 9 objects to choose from, and we can pick 7 of them. Okay, now the combination formula, we take the combination of 9 things chosen 7 at a time, and we turn it into a permutation of 9 things chosen 7 at a time, and we divide it by 7 factorial. Okay, and what this does, dividing by 7 factorial, that actually eliminates all of the duplicates. Okay, so instead of sausage pepperoni and pepperoni sausage counting as 2 different pizzas, dividing by 7 factorial actually only counts those as 1 pizza, because essentially it is just 1 pizza. It's the same thing. Now, from this point, this is where writing out our permutations is helpful. So we've got 9 things chosen 7 at a time, so we've got 7 slots available. 1, 2, 3, 4, 5, 6, 7. Starting at 9 and working our way down all the way to 3. And then on the bottom we have a 7 factorial. So it's 7 times 6, 4, 3, 2, and 1. Now, rather than using multiplying all these numbers on top and then all these numbers on the bottom, the shortcut that I showed you in class is that when we have numbers, we have factors that are the same on the top and bottom, we can actually cancel those out. So 7 divided by 7 is 1. 6 divided by 6 is 1. And we cancel all of those out, and this gives us a lot easier numbers to work with. Make sure we cancel those out real good. Okay, so now all I'm left with on the top is a 9 times 8. I'll write that underneath it. And on the bottom, all that's left is 2 times 1. So on top here, 9 times 8 is 72. 2 times 1 is 2. And then 72 divided by 2 gives us 36. So there are 36 unique ways to take 7 objects out of a pool of 9. So in other words, if this was pizza, we had 9 toppings available, but we could only put 7 on our pizza. You would be able to do that in 36 unique ways. So that's the difference between permutations and combinations. Again, just remember, permutation we do when the order is important. Combination we do when the order is not important.